In this video, I want to discuss the idea of confidence intervals. In general, the idea is I want to be able to move from a sample to the general population. How can I make conclusions about the general population when all I have is a sample? The law of large numbers says that if we repeatedly get a larger and larger and larger sample size, then the sample mean will approximate the population mean. So we can just use the sample mean to approximate the population mean. However, we don't know how close that is to our population mean. There's no idea of how accurate that is. So if we only report the sample mean as an estimate for the population mean, or the sample proportion as an estimate for the population proportion, it's not very informative. It doesn't tell us how accurate that estimate is, and it does not connect a level of accuracy to the sample size. So instead, we're going to look at this idea of confidence intervals. Instead of just reporting the sample mean or the sample proportion, we'll give a range that we think the population mean or population proportion is in. So a confidence interval is an interval which we can assert with a given degree of confidence or certainty that it includes the actual true value of the parameter being estimated, the actual true value of the population mean, or the actual true value of the population proportion. And in order to do this, we're going to have to heavily rely on the central limit theorem. So let's look at the idea of what it is that we want to do. The central limit theorem tells us that if our sample size is large enough, many of our estimators are approximately normally distributed. So we're going to really take advantage of the central limit theorem and the fact that things are going to be approximately normal. In addition, we have the empirical rule for normal distributions, and that empirical rule tells us that 95% of the data is within 2 standard deviations from the mean, so 2 above or 2 below. And in fact, the exact value is not actually 2. It's 1.96, so within 1.96 standard deviations, it holds 95% of the data. So the idea of what we want to do, here I have a normal distribution, and what we know is our sample mean, and we're going to let that be at the center. We're then going to go 1.96 above, so this will be x bar plus 1.96 times the standard deviation, and then 1.96 below. So x bar minus 1.96 times the standard deviation. And then this range right here in between these two values holds 95% of the data. But what it tells us is that there is a 95% chance that the true mean, the actual population mean, is somewhere in this range. So this is kind of the idea of a confidence interval. We're going to go up and down by a certain amount from the sample mean and know that there is a really good chance that that range is going to hold the true population mean. And so this would be a 95% confidence interval. Since we're looking at 95% of the data in between here, we could make this a stricter confidence interval and do 99%. We would do, instead of 1.96, we would go up and down so that my shaded region held 99% of my data. You could do it as 90%. You could be less strict. In that case, we would go up and down by a little less so that the shaded area would hold 90% of the data. So this is the idea of a confidence interval. It gives us an idea of where the population mean or where the population proportion might be.